We're ready. Good afternoon, everybody. Welcome to a nice sunny afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. And I'd like to thank again Jeunesse for finding an error I had for lab 12, which is you're going to do on Thursday. By the way, I'll explain why I said that in a second. I had the same files for 11 and 12 for the labs, which was only for lab 11. Well, that's been corrected. And I'll check it again a little while after class. All right, we got a lot to do today. So let's get going. And by the way, I don't know why I was out yesterday. And I think it's because uh, I've been not out a lot, even though I did have a mask. If I contacted some normal germs, I think that might be affecting me and giving me a little cough. So I apologize if I'm coughing. All right, important things. First of all, thank you, and thank you. You guys did great on test 3. In a little while, I'll be going through that, test number 3. What I'm going to be doing today is 1, I will talk about test 4, which is this Thursday. Is it that way or that way? Thursday is. Maybe it's that way. Anyways, test 4 this Thursday. Next, I'll talk about, hold on, special effects time, the extra credit project, which is optional, but if you do it right, you can get 10, yes, 10, 5 and 5, 10 bonus points. It's like getting 10 more points to any of your exams or just to the bottom line, 10 points, which can only help. It's optional, but I'll explain it. It's fun too. And let's see, I'll go through test number 3 and then a couple other things, and we'll finish up today. Carbohydrates, we may go a little longer. It's still going to get you out before midnight. But anyways, and then we'll do the lab today. Now, before I forget, which I would, no, I probably wouldn't, but I'll do it now. Normally during a semester, I couldn't do this, but in a virtual classroom or online, I can. This week only. Instead of having the lab on Wednesday and the long lecture on Thursday, I'm going to switch them. On Wednesday, we're going to have the long lecture, and Thursday, we'll do the lab this week that we normally would have done on Wednesday. Why am I doing that? Because I can spend more time in the material on test 4 for you to practice. Surprisingly, even though test 4 should be easy, a lot of students just, and I don't want you to go on test 4. So that's why I'm making that change. And because we're online and not in a lab where I couldn't do that, I'm going to do it because that will help you do better on test 4 so you don't get But anyways, all right, let's go through a couple important things. But first, let me open Blackboard again, not Blackboard, wrong school, D2L. Hang in while I'm logging in. Oh, and I almost forgot about something, which I'll also mention. All right, thumbs up, people, if you see test 4, important information on your screen. Thank you. All right, on Thursday, I hope we got the date right, I will give test 4 online. You'll be downloading a test 4 password protected PDF file, which should be available sometime Wednesday afternoon, early evening. And then on Thursday at 2 p.m., because we're doing the lab on Thursday, I can start you off earlier. I will send out right after the lab the password for test number 4 PDF file. You'll have until Friday, 11 a.m. to finish test number 4 and upload it. Upload your test number 4 answers to the assignment area of D2L as a single PDF file. It should take about 40 minutes to finish. If you need some extra time, go right ahead, take up an hour or so. All right, test number 4 will cover polymers, lipids, otherwise known as fats, oils, and steroids, and carbohydrates. Test number 4 has 9 pages, 20 problems. Some of the problems are multiple part. In Chem 170, I never have, never will give a multiple choice. Here's the point breakdown. General knowledge 54. Whoa, I'll explain that in a second. Nomenclature 15, reactions 36. And that adds up to 105. As always, this test, all my tests are not open note. I'll do a review tomorrow for test number 4 material. We'll have our regular Zoom meeting for our lab and other material. And I'll explain in a little while. Don't forget the deadline for the extra credit project is the 26th of this month, which is coming up soon. Not that far away. But anyways, let's look at this. General knowledge, 54. Well, if you think about material and carbohydrates, if I ask you, is my right hand chiral or achiral? It's chiral. Actually, this is my right hand. My right hand is chiral or achiral. Chiral is the right answer with that question. Well, it's not nomenclature. It's not reactions. So it must be general knowledge. If I ask you to circle the chiral carbons, well, it's not nomenclature. It's not reactions. Well, it must be general knowledge. And that's why there's a lot of points in general knowledge more than normal. So, any questions about test number 4? Oh, I still got to get that fixed. All right, let's go on to something else very important. Some of you are missing labs. I've decided, I put this out as an email, also as an announcement, and that is the Lab Amnesty Program. Because we're online and I don't get to pester you that often, and even sending out emails, I don't know if people read them, I decided to put this up and send this out. Some of you have not handed in all the labs. I'm offering a lab amnesty program, and that program is if you do not have a score for a lab in D2L, look in the grade book of D2L, because this morning or yesterday, I uploaded up through the last lab that was handed in. You should email me because the link's probably no longer active. The lab or labs that you're missing before Saturday, this Saturday, the 24th, by 10 a.m. in order for me to grade that lab that was due, that was already due to be handed in. This week's lab is not covered under this because you have today you're handing in one lab and Wednesday another, or Thursday actually. And if after that date and time, I will enter 0 for any lab that was due but not submitted for grading by today, that was due. So make sure, if you need a copy of a lab, email me and I'll send you the lab or labs you need. So make sure, check D2L grade book. If you had emailed me a lab, I'll be very honest, I might have missed it, and do it again, and I'll grade it, no penalty, points will be taken off. The reason why I might have missed it is I have 4 email accounts, one from Elgin Community College, one from College of DuPage, my personal one, then I have a business I consult, and I get anywhere from 5 to 40 emails a day. I'm not talking about spam or junk. That goes into the junk file. I'm talking about bona fide emails that I should either consider that I read it or delete it, but they're verified emails that are not junk. So once in a while, I will miss if you sent me a lab to grade, not through the normal D2L interface of assignments. So make sure you do that. And now one more thing I get to talk about. We go to the assignment areas of Blackboard, wrong school, of D2L. I'll put it in edit because, oh wait, hang on. This is a new feature in D2L that they didn't have until this semester. All right, thumbs up, people. Do you see the assignment area of D2L as you would see it? And you see extra credit project. I'm going to click on that. And this is an optional project. Oh, let's click on one of these files. I'm going to open it with Word. I'm going to make sure you can see it. Does everybody see the extra credit project? And let me make it a little larger. And what's this extra credit project? It's 10 bonus points. Oh, wow. And what do you have to do? Create a chart that contains 10 organic, and I mean organic, water, sodium chloride, ammonia, other things like that are not organic, 10 organic molecules which are found in ingredients list of commercially available products, meaning something you can buy. You can use a molecule only once in the chart, but you can get up to 3 molecules per product. That makes you look at more than one product. Now, to get a full credit for a molecule, all entries in the row of the chart must be correct. Also, to get 10 points, you got to have 10 correct or 10 entries. By the way, if you give more than 10 and they're wrong, I take off points. It's not my job to determine what's right or wrong. Now, for each entry, record the name of the product, the name of the molecule, and one of the functional groups, if there's more than one, the molecule, or the only functional group if it's the only functional group in that molecule. Be sure to put your name on the chart, and the following indicates how it should look. Your table, product, and I took brand X wine, and the molecule ethanol, and it's a functional group alcohol. Now, to make it interesting, there's certain molecules you can't use. Sucrose, ethanol, isopropyl alcohol, acetone, ethyl acetate, propane, acetic acid, or methane. There are certain products you can't use. Beer, wine, vegetable oil, vinegar, gasoline, propane gas, natural gas, orange juice, milk, sugar, butter. Everything else is fair game. Now, this is important. One, ingredients must appear on the ingredients list on the product. And from the lab you hand in, esters, you know that bananas contain isoamyl acetate. That's the ester that makes it smell and taste that way. Guess what? I've never seen in a supermarket banana or bunch of bananas that has an ingredients list on it. So you can't use that. And they must contain a functional group that we discuss in this class. There are other functional groups. However, when students try and use those, they always get it wrong. And since I put this in that they must contain a functional group discussed in this class, scores have gone up on this. This is due by the end of the day, January 26th. July 26th. No late projects accepted. Please upload it as a single PDF or MS Word file. This is optional. You don't have to submit it. Now, word of caution, beware, not all names on labels are UPAC or even common names. Simethicone is not a ketone, it's a silicone compound. Now, how do you find out what functional groups are in there? Well, you can use Google, put the name of the compound, and then the word chemical structure, and one of the first two hits will help you see a structure. Or you can ask me for help. So let me do something because I didn't bring it in. Hold on, I'll be right back. I'm back. Can everybody see this? Thumbs up, people. It's CarMax, and I don't get any kickback from the company, even though I've been a long time user. And what's it for? In the winter, in case your lips get chapped, you put this on there. And when you put it on, it tingles. Why does it tingle? Well, if you look, and I don't have my bifocals on, don't tell anybody I wear them, it says in ingredients, one of them is phenol, or in the active ingredients, phenol. So for this is, you can use this, put down Carmex, phenol, and you have two choices. Either it could be an alcohol or an aromatic compound, or you could have put down benzene ring. I would accept that as a functional group. And you'd get your 1 point. And by the way, if you look at the label, there are two more you can get out of here. So if you happen to have this at home, or next time you're at a drugstore or supermarket, take your cell phone and take pictures of some labels, ingredients list. You don't even have to buy it, and that's how you do it. Now, important misconception. People think, students think, I don't know where they get this, and that's why I'm telling you, you have to have 10 different functional groups. No, they can all be alcohols, or they can all be ketones, aldehyde, whatever, or a mixture. But the key thing is you can only get 3 compounds from a product, which means you got to look at 4 different products. That's my way of making you look at labels and think about these contain organic molecules, chemicals, and you'd be surprised what's in some of the stuff. Now, make sure it's a functional group we use in the lab, I mean, in our class. An example, a beta-ene we didn't talk about. I know what they are. And some other functional groups, ketenes we didn't talk about. You aren't going to find that. But anyways, keep it to that. And that's how it is. Now, as a public service to you, before it's due, send me your list, email it to me, and I will, guess what? Check it and tell you what's right or what's wrong. And that way, if you've put a little bit of effort, there's no reason why you shouldn't get, yes, 10, 10, 10 bonus points. Any questions on the extra credit? All right, let's get back to carbohydrates. That's not carbohydrates. Oh no, before I do that, my mind's in left field today. All right, everybody's about Test number 3. I don't know about you, but if I were in your position, I'd ask, all right, 3 tests. What grade am I getting right now in Chem 170? Good question, and I'll answer it. Now, there are 2 ways you can do this. Let's do method A. This is assuming you've handed in all the labs and done well. And if you've handed in the labs, most of you've done quite well. Take the sum of your 3 test scores. You've had 3 tests. Divide that by 3, you're going to get a number X. If that number is 90 to 100, you're getting an A. If that number is 80 to 89, B, 70 to 79, C. I don't think anybody's lower, thank God. All right, that's one way. Take the sum of your 2 highest of the 3 test scores, add it up, divide it by 2, you'll get a number Y. And if Y is 90 and above, you're getting an A. If Y is 80 to 89, B, 70 to 79, C. And thank God nobody's below that. Sometimes I've had that happen, but not this summer. And that's where you stand. If you have any questions, remember, from now on out through the end of the semester, my office hours are Monday, Wednesday from 5 to 6 p.m. If you need any extra help outside of that, let me know. I'll see if I can fit you in. Any questions on this? All right. Again, don't forget, do the extra credit project. I've already given you 1 point. You could put down Carmex, phenol, alcohol. Remember, on the extra credit project, you don't have to have all different functional groups. You don't. And this I won't cut out. If I look, let's take a break right now. Come back at 1:48, 5-minute break, and we'll do some more, finish up carbohydrates, and then we'll do the lab. The lab is lightning quick for me to talk about. And I should get you out of here well before midnight. All right, let's take a break. Come back at 1:48, give or take a minute. I'll be back. Hopefully you will too. let's get going. Don't forget, tomorrow I will be doing the lipids problem set, and Wednesday I will be doing the um, carbohydrate problem set. And Wednesday I'll have time to go over again because we've sort of rushed a little. A lot of practice with you people on material for test number 4. And let me remind you of something that happens all the time. Some of you are in a good position with the 3 tests. Remember, my grading, you take 4 tests, the lowest is drop. Highlight that, the lowest is drop. Never mind. But anyways, oh no, it's really bad humor Monday. But students, and I've seen this so many times, will say, well, I don't have to take test number 4. I'll get a 0 and my 3 are good enough. And they didn't study for test number 4. And it comes to the final, the material, which is a comprehensive final, first Chem 170, the whole semester. They didn't study for test number 4 that well. Guess what? That part of the final, they do real bad. And guess what? It hurts their grade. So even if you don't think you need it, I'd highly recommend you study for test number 4 like you need every point. And that will help you out also on the final. All right, let's go back to carbohydrates because I jumped some stuff to cover stuff I wanted to cover. So you had time to, we talked about enantiomers, did Fisher projections. All right. I'm going to talk about something, click, the switch is off, but it's still something I feel you should be aware of. It will not be on test 4. It will not be on the final. Now, when we talk about chiral molecules, remember, chiral means having handedness. The molecules exist as non-superimposable mirror images, just like your hand. Anybody happen to go up to a mirror and look, put your right hand, you see this reflection? Not with a ring on, though. That'd be weird. But anyways, and did you try this? What's that? A spider doing push-ups on a mirror? Yeah. Anyways, I said it's awful humor Monday. That was pretty awful. Now, when it comes to enantiomers, they're non-superimposable mirror image molecules. They have identical physical properties except for 2 things. Optical activity, what's that? Well, I'll tell you, and reactivity with other chiral molecules. Now, optical activity and switches off, optically active compounds, those are compounds that rotate plane polarized light. Now, light is made up of waves, and if you have a light source, you have waves going in all directions of the compass. Now, if you have a filter, the light going through that is only one wave, and that's called plane polarized light. And if you've ever seen those really good sunglasses that cut off a lot of the sunlight, those are plane polarized filters. And they cut off all the waves except one. Well, when you take plane polarized light and shine it through a solution of a compound that's optically active, it rotates to plane polarized light to the right or left. And depending on this, if you keep it at the same temperature, same concentration, when it's pure, it will always rotate it one way or the other the same. And to the right, we call dextro-rotary. To the left, it's levorotary. From Latin, I believe, right or left. Dr. White doesn't speak Latin. Other languages, yes. Latin, no. And switch is still off. And when you have a dextrorotary compound, a compound that rotates plane polarized light to the right, use a plus sign. When it rotates to the left in the name, use a minus sign. I'll show you this in a second. Now, and I think I skipped the part. Yeah, I skipped this part. And DL designation for chiral molecules are, you look at the highest chiral carbon with a hydroxyl group, and this switches off, and that would be this one. Remember, 1, 2, 3, 4, 5. This is not chiral because it's got 2 hydrogens. And notice the hydroxyl group is on the right. So this is a D designation. If we're on this side, it would be L. Now, if you put that all together, let me do one thing. I've just gone out to Aldridge. Let me let you see it. Everybody see dextrose, which is also known as glucose on your screen? You notice here it has D plus glucose. And that's what you find on bottles. And nurses have told me they use solutions of dextrose, which is really D plus glucose. That's been on the label to feed people intravenously. Glucose is a sugar that's in your blood. And the D is for the hydrox group on the bottom is on the right. The plus is it rotates plain polarized light to the right. Now, there's no correlation between D and L and plus and minus. You got to go in the lab and measure plus and minus. I can't look at a molecule unless I already know it, but I can't, if I don't, say which way it will rotate plain polarized light. Switches off, but I thought you'd like to know about this. Now, when we talk about reactivity with other chiral molecules, this is quite important. Let's assume a chiral molecules like this and other ones like this, if they're not the right isomer, right stereochemistry, they can't mesh together. And by the way, you have in your body various chiral molecules, and how they interact with other chiral molecules affect you. And that's why medicine, if it's the wrong isomer, might not help you at all, get you well, or could do serious damage. Chirality is an important thing in certain medicines. So I just thought I'd bring that to your attention. You have to take a biochemistry course to learn more about that. All right, switch is still off. I talked about, we have aldoses, which are monosaccharides that contains aldehydes. Ketoses, you've got a ketone. Ketoses, monosaccharides, simple sugars. And I talked about, but let me review it, switches on, not for what's the sugar, it's a general designation for mono or disaccharide. And the most important one, which I mentioned here, is sucrose, which is a sugar. It's your table sugar that you should know is sucrose. And that's not even the IUPAC name, but that's the common name everybody uses for table sugar if you're a chemist. Now, I talked about D-glucose and its cyclic form, and I'll go through this in a second. And by the way, D-glucose, as I showed you earlier, to use in intravenous feeding, is the sugar that's in our blood. And I won't ask anything on this slide. You don't have to know the structure. And fructose, which is a ketose, is sweetest sugar gram per gram available. That's found in corn syrup. And it forms a cyclic form, which I'm going to go through again. I talked about Hawthorne projection, not on the test. And let's go through this once more. All right, does everybody see, know this on your screen? Thank you. My morning class, they're very slow with their thumbs up. I'm trying to get them to be faster. You guys are really fast. Now, here's a general reaction you learned for test 2. Now here I have an aldehyde. On carbon C5, I have an alcohol. And when it's in the same molecule, you do not need a catalyst. And this hydroxyl group attacks the carbonyl, or just like this alcohol does. And this is an equilibrium. And what's not affected in this reaction, I'm going to redraw. And remember, this is glucose. It's an aldehyde. And what happens is this oxygen is this oxygen. This carbon is this R group. This oxygen will be bonded to what was the carbonyl carbon. That's what this line is. It will have still the hydrogen that was here, but now it will have this hydroxyl group. And on a test, if I give you this, you should be able to draw the product. If I give you the product, you should be able to draw or give the name, if you're lazy, glucose. Either one will work for me. You'll see that in the practice problems we'll do on Wednesday. All right, this is for glucose. I'm going to take a drink while you write that down. If you're done writing this down or you don't need me to do anything more and go on, give me a thumbs up. All right, I think everybody's done. Remember, you can go back and look at the video for today, which will be on later tonight or early tomorrow morning. Now, for fructose, now we have a ketone. And similar to here, the same reaction will happen. Let me rewrite it underneath. Here, our prime is not hydrogen, it's carbon, it's a ketone. And again, the same hydroxyl group or alcohol in C5 will react and attack that carbonyl carbon of the ketone now. Now, what's not involved, and again, this is an equilibrium in the reaction, will be still there. This oxygen right here in our group is this one. So here's what was my carbonyl carbon, and now I have a bond to it. What else is on there? Hydroxyl group. And that's how you do that. And you should know, if I give you this structure, how to draw this. If I give you this structure, you should know either how to draw the starting material or write down fructose. And that you should know. All right, everybody got that written down? Who wants to? Give me a thumbs up. I see two already. The other two of you who are here today, and thank you for coming. All right, it looks like everybody's ready. Again, you can go back and look at the video for today and let me move on. Now, I already talked about reductions, so I'm going to skip that. And I started to talk about glucoside, or the following reaction, which I'll show you. Remember methanol. What does that mean? Well, let's take a look. I showed you last week, and I won't go through the mechanism, it's in the video. If you have a hemiacetal and you react it with acid and another alcohol, instead of making a symmetrical acetal or ketal, you replace the hydroxyl group with OR triple prime. Everything else stays attached. And this, you replace the hydroxyl group here with the OR triple prime from the from the alcohol. Oop, got too much. Now this carbon right here is this carbon right here. This hydroxyl group is this hydroxyl group. Now if I react this with methanol and acid, here's my R triple prime. Everything else stays the same. So I'm going to draw it. Everything stays the same. The only thing that changes that becomes what's our triple prime methyl oxygen, and that's this right here, CH3. Now, why is this an important reaction? Well, I'm going to show you a little while. If this type of reaction didn't happen, we wouldn't have any starches. Oh no, that's not good. So let me give you one to try. Oops, Dr. White made a mistake. And he caught it. Remember, the carbon with the hydroxyl group is the carbon bonded to the carbon with the hydroxyl group and, or the oxygens here. Your turn. Draw the structure, organic product or products for the following reaction. And when you're done, give me a thumbs up. And to help you out, since you're just learning this, and this reaction, I'll never give a synthesis problem on. That's not fair. And that should help you out. Remember in this, R prime and R double prime are connected through the ring. Well, one person's done. And when you're done, give me a thumbs up. All right, I think everybody's done. Let me get to work. What's different? Well, when you see the cyclic form of glucose, think of this reaction. This hydrox group is this, and it's replaced with OR triple prime from the alcohol. In this case, N-propyl. What's the only thing that will change is this. Everything else stays the same. So I can just copy it. And this changes what's R and propyl. And that's what you get. Now, why is this so important? Good question. Or better yet, what is the reason this is so important? All right, I'm going to be writing something on the whiteboard. Do not copy it down. You'll understand in a little while. And bear with me. If I were in a classroom, you'd have to wait while I write this on the board too. Oops. Oops. Oh no, you're seeing duplicate or even now triplicate of the same molecule, the cyclic form of glucose. And yes, you are. All right, first of all, one thing. In your body, we have things called enzymes. Those are really catalysts. And most of the enzymes are just fancy way of adding H plus. Now, if we look at, let's call this A, B, and C. If we look at A, we have this right here. Again, you don't have to write this down. And if we look at B right here, I have an alcohol, which I'll call R triple prime OH. If I had an acid catalyst, we just did, I'm not going to put the acid catalyst in right now, but if we did, we replace the hydroxyl group on this carbon with the OR triple prime. This is still this. And that's what happened. Well, what Mother Nature came up with is this alcohol, only this one, can react and form a bond there. And when it does, it forms this new bond, which I'm not going to erase this. And this oxygen here is now bonded to that carbon. And A and B are linked together, what we call an acetal linkage. But now if we look at B and C, the same thing can happen. This carbon and this hydroxyl group can undergo this reaction. And when it does, what happens? The same thing. This bonds to that carbon. Now you have A, B, and C linked together with acetal linkages. But now, and I see someone about to ask a question. Oh, thank you. All right, now if I had more like D and so on, I can link a lot of glucose molecules. Remember, this is glucose originally in this cyclic form together. And you can do 50, you can do 100. And you know what happens when you react a lot of glucose plus a lot of glucose? With an acid catalyst like an enzyme, you get a starch. And all the starches in our life are made of a polymer of glucose by this reaction. I will never ask this on a test, but now you understand, and you should know this, that glucose reacting with itself will form starch. And different starches can be the things we eat, and also some starches are called cellulose, the things that make up the plant cell walls. Now, Dr. White's really out of his comfort zone because last biology I had freshman year of high school. So what does this mean? First of all, take a lot of glucose together, you make starch. Now you can do the same thing, but I will not write the structures, but you should know if I take glucose and react it with fructose with an acid catalyst and enzyme, I'll get sucrose, table sugar. And this you should know. Sucrose is this glucose and fructose hooked together in an acetal ketal linkage. Now, let's consider what is starch? What is sucrose? It's this polymer, and what do you have right here? An acetal or ketal. It's not symmetrical, but it's still an acetal or ketal. And by the way, switch has been really on for all this stuff. So let's look at the following. And if we take a starch and react with acid and water, like in your stomach, what happens? Well, let's remember test number 2. And I'll write for the symmetrical one. You get back the aldehyde or ketone you would have used to make this acetal or ketal, plus the alcohol. But in fructose, which makes this, the alcohol and the original aldehyde were in the same molecule. So guess what? When you eat starch, your stomach breaks it down to glucose. And that's why this is the most abundant sugar in nature, because we break down our starches to make glucose, which travels in our blood. And animals, when they eat hay or stuff like that, they break down those starches because they can do that. We can't, and I'll explain later why, if not today, tomorrow. But you should know this. Now, if we look up here, sucrose is fructose and glucose hooked together as an acetal ketal. And the same thing, If you had tea like I did this morning and my oatmeal, which don't tell anybody, but I put a little sugar on that too, sucrose, if you eat that and you swallow it and it goes in your stomach, and one of the miracles of life I always think about, at least for me, it's a miracle, that I have in my stomach cells that make hydrochloric acid, and so do you, H plus. And I've been drinking water, and I know you have too. So there's water and acid in there. And guess what happens when you consume sucrose? You get glucose and fructose broken down, and your body uses it for whatever it uses carbohydrates. Now, I'm going to take a switches off, but a little personal thing I'd like to talk about. Over the last 10, 15 years, there have been a number of mothers groups who have said to the food companies in the nation, our children are being harmed and have serious medical problems because of the high fructose corn syrup in food products. They're consuming all this fructose, and fructose is dangerous for you. Now, on a certain level, they're right. On a certain level, I personally believe they're way wrong. Well, anyways, the food companies wanting to keep on selling stuff to people, especially children and the mothers of children, said, oh, we've heard your concern. And guess what they did? They took some of the fructose out, which is high fructose corn syrup. And what did they replace it with? Sucrose. And in your stomach, you're still going to make fructose. So I don't buy the argument that fructose itself causes things like autism and everything. And again, this is my personal opinion. What I do know, and unfortunately I know from firsthand, trust me, I'm not thin. I wish I was, but I'm not. Never will be, I guess. But anyways, the calories and how much sugar, no matter what type, I think is causing the problem. If you have children who are obese, taking in too many calories, that's going to cause health problems. But that's my personal opinion. Now, leaving my classroom this semester and also for test 4, there are a couple things you should know. I'm going to cover them right now. The first thing you should know, and we covered it with fats and oils, you should know how to describe with words in a general chemical reaction what happens when you eat food with fats and oils in it. And how do you do that? Let me show you. When you eat something with a fat or oil, how do you describe this with words? Well, what's the functional group in fats and oils? Ester. And because it's in your stomach, that's acid, hydrolysis, acid and water. That's how you describe it with words. And what's the general reaction? You learn this for test number 3. Ester plus acid and water gives a carboxylic acid plus the alcohol you would have used to make that ester. You should know how to describe with words and a general reaction what happens when you eat something with a fat or oil in there. The functional group in a fat or oil is an ester, and therefore in your stomach, acid and water, acid hydrolysis of an ester, and here is general reaction. Ester plus acid and water yield a carboxylic acid plus an alcohol. Next, you should know how to describe with words in a general reaction when you eat a carbohydrate. And how do we do that? What functional group is in a carbohydrate? Well, it's right here, and that actually is an acetal linkage. So what holds together glucose in a polymer? An acetal functional group. But since we learned it the other way, both, first of all, how do you say that with words? Well, in your stomach, there's acid and water, so that's acid hydrolysis of an acetal. And that's really what starch is, polyacetal. A lot of glucose reactions linked together by an acetal functionality. And for test 2, you learn an acetal or ketal, and I'll let you write down both, reacting it with acid and water. You get back the ketone or aldehyde you would have used to make that acetal or ketal, plus the alcohol you would have used to make that acetal. And for those who want to put 2, you can, but it turns out this is one of the alcohols in the ketone aldehyde. We call that glucose, and another ketone alcohols in the other glucose. So when you eat a carbohydrate, how do you describe that with words? Acid hydrolysis of an acetal, because the functional group that holds these together is an acetal. And what happens when you, what's the general reaction? Acetal or ketal, acid and water, aldehyde or ketone, plus an alcohol. You should know these for test 4. You should know these leaving my class. Hint, big hint. All right, there's one more thing, and I'll talk about it tomorrow. I'll remind you again, because I've already done it, how soap works. And I'll discuss that tomorrow in the review. Remember, you should know the structure of soap, how you make a micelle, and like dissolves like. Now, there's a few disaccharide sucrose, which I told you, you don't have to know the structure, but you should know sucrose is glucose bonded to fructose in an acetal linkage. And when you eat this, you get glucose and fructose back. Polysaccharides we just talked about. Now, starches switches off for this slide. Normally, I've shown you just the 1,4 that forms a straight starch called amylopectin, which looks like this. You can also have branched, but here N is on the order of 50 or 100. This is the Hawthorne form of what I showed you. When you hydrolyze it with acid, you get back glucose. Now, cellulose is a little different, and the switch is off on this. Notice one bond is above the ring, one is below. And because of that, the hydrolysis breaking it apart, acid hydrolysis of an acetal, takes a lot longer than when the stereochemistry both bonds to the oxygen are below. And because of that, if you try and eat paper, grass, or hay, you as a human are not going to get nourishment from it. But if you look at a cow or horse or an elephant, they've got massive stomachs that allow them to eat some grass or hay, which has cellulose, and spend a long time doing an acid hydrolysis. And that's why they can break it down to glucose and we can't. Now, one of the things I've tried, and many chemists have, and it's very difficult, how do you do this in a lab or in a plant? Because you can take wood and make it into food, glucose. Well, it's not that easy. Nobody's really perfected that. And tomorrow I'll teach you a few cute, interesting things about glucose. All right, looking at the clock, we're doing good. It's lab time. And today's lab deals with something I've already taught you, and that's like dissolves like. Things that are polar are soluble in polar things, and things that are nonpolar are soluble in nonpolar things. And this lab, if we were face-to-face at ECC, and also with the data I'm giving you, you can find out, am I lying to you? I'm not, but I might be. And the way we determine that in organic chemistry or the chemistry in general, you go into the lab and prove something. So let me open up today's lab. Remember, tomorrow I'll go through the lipids, fats, and oils problem set. And then Wednesday, I'll go through the carbs problem set. And then because I finished up today, which is akin to similar to a week before our test, on actually a little more than a week if we were in the spring or fall semester. Everybody see like dissolves like on your screen? Thank you. All right. Like I said, like dissolves like is an important rule of thumb. It describes that polar substances are soluble in polar substances and nonpolar substances are soluble in nonpolar substances. Water is the most polar substance in our world. Now, in this lab, you'll also be using hexane, which is similar to gasoline, not the same, and that's nonpolar. Now, in this lab, you'll determine if various substances, such as products that you use in your daily life, are polar or nonpolar. How do you do this? By determining if these are soluble in either water or hexane. If a substance is soluble in water, then it's polar. If it's soluble in hexane, it's nonpolar. And how do you do this? You'll determine if certain pairs create a homogeneous or soluble in each other. It makes it fun. Now, if we were in the lab, I'd warn you, hexane is flammable. In our lab, we never, ever allow matches or lighters, period. But it's always good to remind you. There'll be a waste container for all this. Now, in part one, you'll take about 1 to 2 milliliters of deionized water, that's what DI is, put it in a clean test tube, then add 10 drops of the liquid or a small amount of the solid to be tested. Then you mix it either with a vibro mixer, or let me do a quick. If this were a little test tube, and it's about the size of a test tube, a little smaller, never ever mix it like that. No, hold it firmly and go 1, 2, 3, 4. Don't tickle it. You really got to smack it, or you put it on a vibro mixer for about 3 seconds. Then you wait about a minute or two and see, is it homogeneous or are there 2 layers? If there are 2 layers, it's not soluble. If it's homogeneous, the same throughout, it's soluble. And here are the different compounds you use. You do not have to draw structures: acetone, baby oil, ethanol, ethyl acetate, isopropyl alcohol, which I forgot the alcohol, 2-propanol, octane, sodium chloride, starch, sugar, vanillin, Vaseline. I have you do it in a beaker because you'll never get it out of a test tube, and vegetable oil. And I've given you the data. Now you'll do the same thing with hexane, which water is polar, hexane is non-polar. And here you'll do the same thing, but instead of water, you'll put in 1 or 2 milliliters of hexane, small amount of liquid or solid you're testing, mix it, and let it sit for a little while and see if it's homogeneous. Then dump it in a proper waste beaker or waste bottle. And here, same substances, but now you're testing with hexane. And remember, the rule of thumb for like dissolves like, it's a rule of thumb, so it's true about 95% of the time. There are exceptions. And then to have fun, I had students, you, do some mixtures of different compounds, and you shake it. And here's the results. If you put baby oil and vegetable oil and starch, vegetable oil and Vaseline, ethanol, vanillin, then add DI water. Now, here are the questions. And let me point out one question students always mess up, and you don't want to lose a point, so listen carefully. Grease is nonpolar. If you don't have any soap or soap and water, and you've got grease on your hands, what substance that you tested would you use to remove the grease from your hands? And assume after you do that, you're going to use your hands like you normally do, and you want them nice and clean. So remember that for this one. And here's some other questions for you to have fun with. And with that, I'm done for today. Don't forget tonight, I have my office hour, and I changed it for the rest of the semester. It will be from 5 to 6. If you need to see me elsewhere, let me know, and I'll see if I can squeeze you in if I'm available, because I can set up Zoom meetings anytime, but I also have to be available. And don't forget, on Wednesday, we'll do not the lab, a longer lecture, and Thursday, not Friday, you're not here on Friday, we'll do the lab part, and then right after you'll take test number 4. And with that, gang gesund. Goodbye, I'm done for today.